This is number 3 from the 2006 exam. So we start off with the graph of our function f consists of 6 line segments, and g is the integral of f. Now before I go on, I'm going to make a note that means that g prime must be equal to f, which means that this graph that we're looking at is really g prime, so that's a derivative. So for part A, we need to find g of 4. So let's just substitute into the expression that they gave us for g of x. So g of 4 is the integral from 0 to 4 of f of t. Now again, up here, this is the graph of f, and we are looking at the integral from 0 to 4. So what we want is the area from 0 to 4. So that would be this and the trapezoid. Now one thing I'm noticing here is the symmetry, where this triangle here would cancel out the area of that triangle. So we'll just find the area of what's left, which would be 1/2 times the height. The height is 2, times the sum of the bases. This base is 1 and this base is 2. So that turns out to be 3. Okay, now part B. Oh, no, we're not ready for part B. We still have to find g prime of 4. Well, since g prime is equal to f of x, g prime of 4 is just equal to f of 4. And we have the graph of f, and it looks like f of 4 is equal to 0. And now we have to find g double prime at 4. So that's the derivative, right, of g, or that's the derivative of g prime, which is the derivative of f. So the derivative of f would be the slope of this line here. So the slope would be the change in y over the change in x. So we would do (2 minus -2 over 3 minus 5, which is -2. Okay, so now we're done with part A. Part B, we're asked if g has a relative minimum, maximum, or neither at x equals 1. Well, we know that g has a relative minimum or maximum if g prime changes sign at x equals 1. So here's g prime, here's x equals 1, and it does look like g prime changes sign. We go from negative to positive. And since our graph is going from negative to positive, that means that we're looking at a relative minimum. So for part B, we're going to say g has a relative minimum at x equals 1 because g prime, which is f, changes from negative to positive at x equals 1. Okay, and that is it for part B. We've justified our answer. Now for part C, suppose f is defined for all real numbers x and is periodic with a period of length 5. So that kind of makes sense with what we're looking at here, where each of these sections has a length of 5. So that's going to continue for all real numbers. Oh, look, they even tell us the graph above shows 2 periods. They give us g of 5 equals 2, and we need to find g of 10. Well, we can go about that by saying, well, if we integrate from 5 to 10, g prime, that would be g of 10 minus g of 5. Now they gave us g of 5, we know that that's 2, but we need to find the integral from 5 to 10 of g prime. Well, remember, g prime is f, which is our graph above, so we need the integral from 5 to 10. And the integral from 5 to 10 would be equal to the integral from 0 to 5, or from negative 5 to 0. So let's just take a look at this one because I haven't written anything here yet. And the integral would be the area. But notice the symmetry here, that these two will cancel each other out, as will this guy and this guy here. So we're left with this rectangle that has a height of 2 and a base of 1. And 2 times 1 is equal to 2, which means that g of 10 is equal to 4. Okay, and our last task here is that we need to write an equation for the line tangent to g at 108, at x equals 108. So for that, we need to know what g prime of 108 is, that's the slope, but we also need the y value, g of 108. So let's start with finding g of 108. Now, based on what they gave us, they told us that g of x is the integral from 0 to x of f of t. So that would be the integral from 0 to 108 of f of t. Now, we know that our graph is periodic, so we can look at this as 0 to 105 plus 105 to 108. And we know that there are 21 cycles between 0 and 105, because 105 divided by 5 is 21. And we know from our previous work that each cycle is going to give us an integral that is equal to 2. So we do 21 times 2, that'll give us this first value here, plus the integral from 105 to 108. So that's just 3 units into one cycle. So if we come up here, 3 units into one cycle would be, for example, from negative 5 to negative 2. So we already know that these two sections will cancel each other out and that the area of that rectangle is 2. So the integral from 105 to 108 must be 2. So this turns out to be 42 plus 2, which is 44. Now that gives us our y value. We need our slope. So we want to know what g prime of 108 is equal to. Well, we know that g prime is f. So we need f of 108, and again, we know that our function is periodic. So f of 108 would be equal to f of 3. And f of 3 is equal to 2. So our tangent line would be y minus our y value, which is 44 down here. So y minus 44 equals the slope times x minus 108.